Going to start the recording for DRFT131 lecture, November 19. I'll check this schedule first. Today we'll start our last drawing, review homework assignment number 12. And then we have only 3 more classes to go and then the final test. So we are coming to the end of the class. And the agenda for today will be to review homework assignment and to issue drawing number 5. We talked a lot about shell last time, so we're not going to do that. We did also the same with taper faces. We'll not do that. A couple of things about flat shot and add jog section. We'll review that. Flat shot and add jog section. And so let me change these to 3D. And I'm going to go to the layout tab and maybe make this viewport a little bit larger. Zoom all and zoom on that this little building wall that I have. And then we are going to look at the flat shot option that we have here. Let's bring the AutoCAD definition. So the flat shot, what it does, it creates a 2D representation of all 3D objects based on the current view. And so it's a very simple tool to use. So you have a 3D model, and then the flat shot of that creates just a representation of those edges. Let's look at the dialog box. And it's under there in this section plane. Let's try it. And so the flat shot needs to be created. I like to isolate the view with the viewport, but it needs to be done in the model space. And so now we're going to make it a new block here. And all of that is fine. So we're just going to create and specify the insertion point. Maybe we'll place it right here. It's going to factor to be 1. And done. Now I have a lot of objects in this particular case. And so it's probably better to isolate one object, see, because it's starting to do a lot of work there. Um, and this is the flat shot for this particular drawing that I just created. So, oh, yeah, I don't know what's happening. Hold on. Let's share it again. Okay, good. All right, so let's isolate this object and then we'll do it on this object once again. Clipboard, copy with base point there, and we're going to do a new drawing. Make sure the parallel is all set, zoom all, set current view as home. Okay, and so we're going to clipboard paste right here. Okay, and so that's our view. And we're going to do a flat shot. Remember, flat shot is right here. And we're going to create this new object. And this new object is going to become a block. And there it is. I'm just going to select the insertion point. And see, it's going to try to place it's going to try to place the block on the world UCS, right? And so I am going to let it do that for now, and then I'll rotate it. And done. Now let's see if I can rotate that. Use the rotate gizmo. See that? It's kind of, well, I'm not that happy with this. Hidden conceptual and hidden line. Okay, let's do this again because I'm having a little bit of a problem trying to understand what's happening. Flat shot. Include the edges. I don't have a do not show the obscure lines, and let's see if we can create. And see, yeah, this is what I'm looking for, but somehow this is insertion point is a little crazy. There. scale factor 1, factor 1, and the rotation, I want it to be something like that, but 0. I'm just thinking about this, so I'm not speaking, I'm not saying anything yet. So flat chart, ortho on, enter scale factor, rotation angle, and let's say 0, and done. And so what I have here is a view of this object. It's not what I want really, because what I want is exactly this, but as a flat chart, because a flat chart allows you to see this with just the edges. So that's the idea, right? To create the same representation. The 2D representation on the XY plane of the UCS, X and Y. So let me modify the UCS to be on the object here. Just want to see what happens with that. Okay. And now we're going to do the flat shot again. Include tangential edges and do not show the skew lines, because the skew lines are the lines that are behind. So create, and see, that's much better. A little, I guess. So it's closer to what I wanted, although not perfect. But that's the idea. So now UCS to the world again. And you can see then that the flat shot is just a view of the object that only has the edge lines of the object. Even if I do a wireframe view, this is just the outside view of the object as it is. I need to work on that a little bit more because I want to get a better, a true representation of this view, which I'm not getting yet. Let's see if I can rotate this somehow. Okay, so that's that. I'll get more work on that and maybe get back to you. So next will be the jog section. And what it does, it creates a section with a jog. And so let's do a section plane, I guess. Well, I'm not really sure. Let's get back to that. Select section object. Okay, so we'll do a section plane. I'm gonna rotate that section plane this way. And then we're going to see if we can add the jog. And that is, now we could move these. All right, I'm moving that there. Change it, the orientation. But I want to move it back. See if I can do that. Oh no, because this is not there. Yeah. So I can move it like that. And I can increase the jog if I want to with this other arrow. Right. And so that allows you to see jogged section. If I go to the top, we'll see exactly what we're talking about. See, the section creates this indented area there. All right, and so that's it. So see if you can use that for your project. And maybe not in an architectural project, this is a very specific kind of thing, but in a mechanical project, yes, we are always able to do that. Great, so let's move on. I'm going to delete this section. And we're going to now talk about the drawing number 5. Let's look at the assignment. It says here, using your file from drawing 4, create a 3D model of a detail, the component from your previous project. Remember that in drawing number 4 or project number 4, you needed to include a 3D model of a detail component. And now we're going to take that component and we are going to recreate that in more detail. For example, let's say that you did a building. And in that building, there is a door that's got a particular design to it. Now you can take that door and recreate the door itself as a 3D model with all of the details that it needs to be that object. And you say, okay, well, the door doesn't have that much detail. Well, of course it does. It has a lot of detail. It's got many components to it. It got layers. It's got finished layers, structural layers that go inside the door. It's got a doorknob. It's got a rails. It's got a lot of stuff in it. And so we need to recreate it in all detail. And then once we have that detail, then we're going to use these tools called Solve View and Solve Draw to create a presentation. Okay, so it's kind of a two-step process, right? You recreate your model, and then once you have a 3D model of that particular detail, or of that component, then you're going to use these new tools called Solve View and Solve Draw to create a presentation. And this presentation using Solve View and Solve Draw need to have a floor plan, elevation, section, and 4 shaded views using conceptual visual style. Of course, you can also apply the flat chart tool at it, and that's also interesting. So, and then you just submit that. Okay, so what is Solve View and Solve Draw? I'm going to give you a quick introduction to that, and then we'll talk more about that next class. But remember that the next class is on Thanksgiving week. I don't know. Well, I will have the class on Monday, or I mean on Tuesday. Um, there will be no class on Thursday because we are off. So let's talk about that. What is SolveView and SolveDraw really quick. And then we'll review that again next time. So once we build a 3D model, let's say this is my final 3D model. Let's save these as "3D Practice 3." One second, I just need to write down something here. So we have this model here on the model space. And I got two layouts as default, right? So when I start the SolveView tool, it's going to immediately send me to a layout. And that's what I want. Okay, so I'm going to type SolveView. And SolveView is short for solid model view. Before I do that, let's see what does AutoCAD says about that. So SolveView creates orthographic views, layers, and now viewports automatically from 3D Solid, and that's what it does. And so it creates orthographic views, it's going to create layers, and it's going to create viewport layouts. Right? And so let's do it. And that's the easiest way to learn it. SolveView. Yeah, as soon as I press enter, it's going to send me to a layout. And now I am on the layout tab, right? And now the tool is asking me, what kind of view do you want? Because the idea is that this is going to allow me to create views. And so I can do an orthographic view, auxiliary view, or section view. An orthographic view will be an elevation view, for example. And so let's select ortho. And I'm going to zoom out. And now it's asking which side of the viewport. This viewport, the viewport on this layout, which the viewport is that line, has 4 sides, right? 1, 2, 3, 4. It's and the tool, the command is asking me specify which side of the viewport do you want. And so I'm going to click on this side. See, I select that side. And then it's asking me at the bottom, you can read at on the command tab, it's asking me specify this new view that you want to create, center. And I can specify the center anywhere, but it's easier if I do it on this gray space. I'm just going to click, left click. And now it's asking at the bottom also on the command bar, um, specify the viewport. And so I'm going to press enter and I'm going to create a viewport there, see? And you see now that there is something inside that viewport. That's the new view. Also on the command bar, it's asking me again, specify or enter the view name. So I'm going to put here right side, because that's the side I selected from the viewport. And now I'm going to press enter again and done. I just created this new view. Now I'm going to zoom closer to that. So this view is a view of this object from this right side. Now, of course, it's a perpendicular view, as if I'm standing up here and looking at this object. Remember that when I look at the AutoCAD screen, is if I am, as if I am looking at the floor. So if I'm standing on the floor, looking at that object, this is what I would see. Doesn't make any sense, right? Let's undo, and we'll do this again in a different way. Okay. First thing I'm going to do is I'm going to go to the top view here, right? And now I am going to do solve view again. All right, it sends me to the layout. I select orthographic projection, and I'm going to select maybe this side. Now move down here and select, click here to select the new the center for the new view. Now press enter, very important. Create the new view there. And now give it a name. And this is front elevation. Now it makes a little bit more sense. And done, right? I'm not gonna do more views. And now see, this view at the bottom is the front elevation of that object, right? Standing from here. And that's what I want. That's what I want to do. And I can scale this viewport. I can make it as large as I need it. And that's great. But this is still not a 2D view. Now that I created this view, I am going to actually apply the Solve Draw tool, right? So draw. And click on the viewport and press enter. And see, now we have a 2D view of the object. And now we could use that 2D view to lay out my elevations on the page that I need. But I'll do all the views first, and then I lay out the elevation. Now, this is a 2D view. It's not a 3D view. These lines have been extracted from the 2D model. Now that we understand a little bit better, what happens if I turn this again to a 3D and do a solve view? Let's do solve view, ortho, click, present, and that's the view. I'm gonna call that 3D1, something like that. And escape. And now let's apply Solve Draw to this one. see, it creates a 3D view of that. Not only that, but if I get close to these, um, some lines are inside other lines. So now that I created these two views, let's analyze the layers and see when I applied Solve View, the program creates layers. And those three layers are visible lines, hidden lines, and dimensions. And so if I select the hidden line, for example, and AutoCAD suggests that we should create a template when creating these views, but we can do it right here. I am going to select the line type for hidden to make sure that I load the hidden line. And select that. Okay, and also for this other hidden layer. So the two hidden layers now have the hidden line type. And now you can see that the program actually knows which lines need to be hidden and which lines need to be solid according to the location of those edges on the model. And that's what this program can do, right? See here, same thing. We see the elevation view, but we also see the lines that are hidden by the objects. And so that's why those layers were created. So this is what we're going to do. Once you create all these, once you create them all, then you can have the computer draw the elevations and sections and so on. We can create sections also. So that makes it very easy for us in documenting our project, because we can create the 3D model of our project, and then we can use tools like this to create the 3D, the 2Ds. We no longer have to draw. We just use these tools so that the drawings are created off the 3D, the model that we did. And that's kind of, as I said before, this is kind of a turnaround as to when you did the floor plan elevations and sections in 2D and then we moved to 3D. Now we're actually going back from the 3D. We are doing plans, elevations, and sections. And as I said, you could check the accuracy of your first drawings against these ones now that these are extracted from the 3D view. And so that's what we're going to do on drawing number 5. And that'll be our last drawing. So that's all for now. Thank you very much. And I'll see you next time. Let me know if you have any questions. I'll hang out for a few minutes.
Hey, Armando.
Yeah.
I don't know if you got my email, but I was having a little bit of issues with something. I was wondering if you might have a solution.
Mm-hmm. What's the issue?
So I did one of my objects for my drawing. It's a revolve, and I used revolve, and it's still identified as a surface, and I was trying to turn it into a solid by using thicken.
Yeah.
But no matter how small of a